Hello everyone and a warm welcome to GenQA's third Focus On session. Can I ask that if you are dialing in live today, can you please mute your microphones? But if you would like to ask a question, please submit it on the website in the questions box you'll see on the panel. There will be a live question and answer session with our panelists following the presentation today. So today's presentation is a focus on the GenQA EQAs for haematological disorders, and it will be given by Jerry Evans, who's one of our GenQA Deputy Scheme Directors for Cytogenomics. Jerry is a clinical scientist with over 36 years experience in UK diagnostic labs. So I'll hand you over to him now. Thank you.
Hello, my name is Jerry Evans. I'm a Deputy Director of GenQA, and today I will focus on the haematology disorders offered by GenQA. Today I will ask, why do we want external quality assessment schemes? I'll describe the work of GenQA and who we are. I'll talk about the impact of COVID-19 on GenQA, and I'll talk about some of the EQAs we offer. I'll ask what can be learned from EQAs, and I'll discuss the needs of our users with respect to EQAs. And finally, I want to give an insight into where GenQA is going. An EQA provides centres with an external measure of the standard of their service. Genomics Quality Assessment provides a quality assurance service for genomics through a broad, consistent and sustainable range of relevant external quality assessments at a reasonable cost to the genomic community worldwide. This helps to harmonise the quality of clinical service, promote quality across national borders, provides external verification of clinical service, and identifies imperfect practice and improves quality. I come from a laboratory background, and at times it's difficult not to see EQAs being an irritant that is getting in the way of your day-to-day laboratory function. But I strongly recommend that everyone reads the EQA reports and find that we're not being judgmental, but we're trying to educate and improve the standard of service offered to our service users. GenQA is a UK NEQAS member. NEQAS has over 50 years experience providing EQAs from 25 specialist centres. The EQAs are ISO 17043 accredited. We have worldwide participants. It's a charitable organisation which is self-funding and not profit-making. GenQA has been offering EQAs since 1982. GenQA offers more than 100 EQAs for genetic and pathology laboratory testing, as well as clinical genetics EQAs. GenQA provides a training and competency tool, GTACT, and this year we've had a GTACT module for COVID swab taking in care homes. We are based in Oxford and Edinburgh, and we're the largest genomics EQA provider. This is a screenshot of our new GenQA website, which we hope will be more user-friendly and encourage people to visit our educational resources and help make it easier for people to register for EQAs. Obviously, COVID-19 has had a massive impact worldwide, and GenQA has not escaped the impact of COVID-19. COVID-19 has increased the pressure on laboratories who we rely on to provide samples, to carry out our validation, and to provide members of staff who can assess our EQA returns. And this has led to challenges for ourselves in GenQA with regard to the logistics of launching our schemes. GenQA's response to COVID-19 has been to have bi-weekly operational teleconferences. We've seen more remote working. We've delayed all EQAs while we've been through lockdown. Some of the EQAs have been modified, and we've allowed increased flexibility with respect to submission dates to our participants, and instead of the usual assessors meetings in physical, we've moved to more virtual meetings. Cytogenomics plays an important role in the management of hematological neoplasms, which is reflected in the large number of hematology EQAs that is offered by GenQA. Cytogenomics plays an important role in diagnosis, classification, prognostication and disease monitoring of hematological disorders. We try to reflect the importance of this work in our EQAs. We receive real samples from real patients from laboratories across the world, which we send to our expert assessors to validate the results before using them in an EQA in as close to a clinical setting as we can. This, in a nutshell, is the EQA process. Samples or images are received from supplier labs with clinical background. These are sent for validation to at least 2 independent laboratories using different procedures who will inform us whether they think the samples or images are suitable for use in an EQA. Suitable samples with processing information and referral details are distributed to our participants. The participants are given a set period to carry out their analysis, and the returns are then sent on for assessment. The assessors initially mark 6 cases and feedback on the marking scheme. At this time, any modifications to the marking scheme can be made, and then the assessors carry on their assessments, and at the end of the period, when the assessments are complete, we'll hold an assessors meeting. This is then to thrash out any differences that may have arisen in the marking, and after this time GenQA produces individual laboratory reports which the laboratories can appeal should they feel there have been unfairly deducted points or there are unfair comments. The appeals are reviewed, and following the appeals, the final report is reviewed by the Specialist Advisory Group before being published. A poor performance from a laboratory means that they have additional steps to perform, including completing a poor performance incident form. I'm reliably informed this is what the hounds of hell look like, but on a more serious note, GenQA is not here to punish laboratories. We are here to help laboratories with problems and hopefully find an issue, a way to resolve any problems, which may be a training issue. This is a list of the hematology EQAs for 2020. In the analysis and interpretation EQAs, we provide material or images to accompany a case scenario. We ask for it to be analysed and reported as a diagnostic sample with recommendations for further testing as appropriate, as you would a routine sample in your own laboratory. Today I'm going to mainly concentrate on CLL, chronic lymphocytic leukemia, which is the most common adult leukemia in the Western world. It's caused by an overproduction of abnormal lymphocytes in the blood and bone marrow. It mainly affects adults over 70 years, but it's generally an indolent disease which progresses slowly. This year we're offering 3 EQAs relevant to the processing of CLL samples in the diagnostic laboratory. We're also offering 2 pilot EQAs which would hope to make full EQAs in 2021. To Traditionally, CLL has been investigated using karyotype analysis of blood and bone marrow samples. However, it's become more common to analyse interface FISH from peripheral blood lymphocytes, and this has shown that cytogenetic lesions are present in greater than 80% of CLL cases. And we use FISH and G-band analysis to look for prognostic indicators in CLL. So the EQAs are designed for the laboratories to identify the correct abnormality, to understand the limits of the test, to indicate further testing as required, and to be aware of the prognostic significance of their findings. The most common chromosome abnormalities seen in CLL include deletions of chromosome 13, deletions of chromosome 11, trisomy 12, and deletions of the short arm of chromosome 17, and these therefore provide the basis of the mature B&T G-banded online EQA. This is an online case where the patient showed lymphocytosis and the haematologist was asking, is this CLL? This EQA provided G-banded images. The validated results showed a deletion of the long arm of chromosome 6 in 8 cells and normal 46XX karyotype in 6 cells. The EQA also provided FISH images which show there's no deletion of chromosome 11, 17p, 13 and no trisomy 12 in this case. The validated results in this case showed a cytogenetically visible deletion of chromosome 6 and a normal cell line. There was no deletion of ATM, there was no evidence of trisomy 12, there was no deletion of 13q14 and no deletion of TP53. The deletion of the long arm of chromosome 6 is associated with an intermediate prognosis in CLL. The assessors considered that a minor variation in the written ICN was acceptable given the quality of the G-banded cells provided. FISH images were provided so a full analysis was possible, which showed no deletion of chromosome 17p, 13q, 11q and no evidence of trisomy 12. 11 of 44 laboratories did not provide prognosis. GenQA had not requested prognostic significance in this case, but it is considered to be good practice to provide a prognosis. This EQA sample was a blood sample received from a patient with a new case of CLL. All the G-banded metaphase cells provided in this case showed a normal 46XX karyotype. This EQA also provided FISH images, which showed no evidence of trisomy 12, but did show deletion of 13q at the DLEU1 locus. Additional FISH images were provided, which showed no evidence of loss of ATM nor loss of TP53. So in summary, this CLL case showed normal 46XX karyotype with no evidence of trisomy 12, nor deletion of 11, nor P53, but did show a DLEU deletion by FISH. This case showed a 46XX karyotype. FISH demonstrated a submicroscopic deletion of chromosome 13, which did not include RB1, consistent with CLL. The 13q deletion as a sole abnormality is associated with favourable prognosis in CLL. However, in this EQA, we were not asking for the prognostic significance of this finding. However, as policy and guidelines changed, it was recommended that a statement with regard to testing for TP53 deletions or mutations and IGHV status should be carried out on the back of this finding. We've seen from the mature B&T G-band EQAs that G-banding alone may not necessarily pick up all deletions seen in CLL, and this is where they are complemented by the mature B&T FISH EQA. For chromosome analysis, we need dividing cells and we need to produce a preparation of sufficient quality for chromosome analysis to be performed. The problems of karyotyping neoplasms has long been recognised, so many commercial companies have developed kits to allow FISH testing for certain disorders. So we can purchase a CLL kit which we would expect to have probes to identify deletions of chromosome 11, deletions of chromosome 13, 17p deletions and trisomy 12. In this EQA, we distribute fixed cells and request the laboratories process the samples to identify the prognostic indicators for CLL. The validated result for this case of CLL showed no evidence of deletion of ATM, 13q14, TP53 and no evidence of trisomy 12. The minimum FISH testing required for a new case of CLL is to look for a deletion of TP53, but the implications of a normal FISH result are less clear than an abnormal result with regard to the prognosis. This is a confirmed case of CLL, and the haematologist was wishing to know whether there were signs of disease progression. What this EQA is asking is what is the level of disease in this blood sample. The validated result showed a deletion of ATM in greater than 70% of cells, with a normal signal pattern for TP53, chromosome 12 and 13q probes. Validated results showed an ATM deletion in greater than 70% of cells in this case. A few laboratories were only able to demonstrate a deletion of ATM in a lower frequency of cells. The assessors therefore advise that analytical procedures are reviewed in such instances. All laboratories tested for or arranged for testing for TP53 deletion and ATM deletion. One laboratory seems to have misinterpreted the question and tested for transformation of CLL rather than disease progression. The acquired array EQA is suited to conditions where we see a genomic imbalance or where we might see complex karyotypes, for example in chronic lymphocytic leukemia. This again was a new case of CLL, and we're asking for ACGH to be carried out on the DNA sample we supplied to look for prognostic indicators. This was a new case of CLL, and we asked for prognostic indicators after we carried out array CGH analysis. Validated results showed a 26 megabase interstitial deletion of the short arm of chromosome 4 and two submicroscopic deletions of 11q22.3, which included ATM, and a 1.14 megabase interstitial loss of 13q14.2 to 14.3, which included the D-Lu genes. The validated results from this sample showed a deletion of chromosome 11 and a deletion of chromosome 13, both of which are recognised as recurrent adenomatous in CLL and associated with an unfavourable prognosis. It's recommended also that the status of clinically significant genes are included in the report. So in this case, we would say deletion of chromosome 11q, 13q, but there's no evidence of a deletion of chromosome of TP53. And it's recommended that for complete prognostication, TP53 mutation screening should also be carried out in cases like this. This is another acquired array CLL case with which is a new case but confirmed CLL. Validated array CGH results in this case showed a 5 megabase type 2 deletion of chromosome 13. This included a 1.2 megabase homozygous deletion of 13q 14.2 Q14.3. There was also a small 4 megabase loss of 14q 24.2 Q24.3, which contained no clinically relevant genes and therefore was not expected to be reported. We expected our participants to detect an abnormal female profile with mosaic type 2 deletion in the long arm of chromosome 13, which included a biallelic deletion in this region, and to correctly recommend TP53 mutation testing to be performed in this case for full CLL prognostication. A statement regarding the status of clinically relevant genes should be included in the report, as clinicians may not be aware that genes have been explicitly tested, e.g. to state no loss of TP53 was detected. A few participants incorrectly reported the small benign 14q deletion and described it as being the recurrent deletion seen in CLL. We know that TP53 and IGHV mutation status is important for prognosis and response to treatment. It is important that TP53 mutational analysis is carried out, as often patients have a deletion of TP53 on one allele and a mutation of TP53 on the second allele. Patients may show normal TP53 copy number but harbour a sequence mutation within the gene, and these are associated with poor prognosis. IGHV somatic mutation analysis is important, as patients with a mutation generally show better response to treatments than patients who have not got the mutated IGHV locus. So 2020 has seen us launch 2 pilot EQAs for TP53 sequence analysis and IGHV mutation sequence analysis in collaboration with ERIC, the European Research Initiative on CLL. In CLL, the chromosome abnormality is often a prognostic indicator for that disease. In lymphomas, the chromosome abnormality defines the disease and the disease prognosis. This is a G-banded cell from an individual, and the hematologist is asking, is this Burkitt's lymphoma? And the G-banding, as we can see here, shows an 822 translocation. This EQA also provided FISH images, and in this case it showed there's a rearrangement involving MYC. Chromosome analysis showed a variant Burkitt's lymphoma karyotype with a T822, and the involvement of MYC was confirmed by FISH. Additional FISH testing was carried out and showed no rearrangement of BCL2 or BCL6. Validated results showed a T822, which is a variant translocation of Burkitt's involving MYC and IGL. What was crucial about this investigation was the absence of involvement of BCL2 or BCL6. A rearrangement involving MYC and BCL2 and or BCL6 and complex karyotype is seen in diffuse large B-cell lymphoma. So it's considered that as there's no involvement of BCL2 or BCL6 and this was a simple karyotype, that the most likely diagnosis was of Burkitt's lymphoma. In this EQA, a lymph node was taken and cultured for karyotyping and FISH to determine whether a lymphoma was a cause of this patient's problems. G-banded karyotype showed an interstitial deletion of chromosome 10 and an apparent 14-18 balanced translocation. This EQA also provided FISH images which showed there was no rearrangement involving BCL6 and no involvement of MYC. FISH using IGH BCL2 dual colour dual fusion probe showed normal signal patterns as on the left and showed translocation signal pattern as shown on the right. So karyotyping showed a deletion of chromosome 10 and a translocation involving chromosomes 14 and 18, which was shown to involve IGH and BCL2 by FISH. There was no rearrangement of BCL6 and no rearrangement of MYC. So the 14-18 translocation is associated with follicular lymphoma and to a lesser extent diffuse large B-cell lymphoma. A deletion of chromosome 10q is a recurrent secondary abnormality associated with the translocation between 14 and 18. And the prognostic significance of this finding is the prognosis associated with follicular lymphoma. The translocation 14-18 involving IGH and BCL2 is a recognised finding in B-cell lymphoma. This includes follicular lymphoma on diffuse large B-cell lymphoma. The referral reason for this case was not specific to a particular type of lymphoma, and therefore assessors expected that information relating to possible differential diagnosis should be included in the report. For lymphomas, the disease is defines the prognosis, so no prognostic statement is expected. Our EQAs use real samples from real laboratory situations, so we expect our participants to treat them as they treat a regular diagnostic sample. But we appreciate that as knowledge and guidelines and technology changes, what applies one year may not be relevant the following year. So our EQAs have to evolve with the times. GenQA is the largest provider of genomics EQAs. Some of our EQAs have a very large number of participants, which allows us a good oversight of genetic practices in the laboratories. Some companies enter our EQAs to use our status to test their products. Looking at a lot of laboratories' returns, we can get feedback and provide feedback for whether a probe set is appropriate for that test or whether it's a combination of probes as others that might have been used in other laboratories. We can see trends in laboratory practices, and particularly we're seeing reduced traditional chromosome analysis being carried out in the laboratories, and this does have issues with regard to training and competency. And we can feed back to laboratories that we think that a clinical laboratory should, for example, be able to identify an abnormal clone at a lower level than they may well be quoting in their report. So in GenQA, we need to listen to our participants and react accordingly. So we've heard this year that we are moving towards a sequence-based testing, that labs are rarely carrying out that particular test, that they will carry out that FISH test on one type of sample but not on another, and that they won't get reimbursed if they carry out that test in the diagnostic service. So we have to think about how to accommodate this and how to evolve our EQAs with advice from the Haematology Specialist Advisory Group. Our participants are telling us that in some cases they're having to sign up for a full EQA and only taking part in part of that EQA. For example, many labs are telling us we don't do MDS by array CGH, that we don't do G-banding on CLL. We've heard that certain labs are moving towards sequencing based techniques for CLL rather than using array CGH. So some of our EQAs are being paid for and not used fully. So from 2021, we're looking to make our EQAs more disease based. Several will remain the same: myeloid, ALL, myeloma, technical FISH, and mostly acquired array. But for the CLLs and the lymphoma, we'll look to have an EQA specific for CLL and lymphoma testing, and hopefully to introduce the TP53 and IGHV mutation analysis EQAs after the pilot this year, with proposals for other pilots too, which will roll out sometime in the future. So we propose our EQA changes will follow patient pathways. We will see that there are some changes to our current EQAs, but we're providing relevant EQAs to our participants, and we're responding as technology advances. And we're evolving our EQAs so we can continue to provide the best EQAs we can. I'd like to thank Sandy Deans, Ros Hastings, Melody Tabiner and Katrina Rack for helping putting this presentation together. I'd like to thank Jenny, Jenny Fairley, our technical whiz, for helping putting this focus on together. And we have to give a big thank you to all our haematology genomics assessors from all around the world, without whose help GenQA couldn't function. Thank you.
Thank you, Jerry. So we'll be moving on to our question and answer session now with our panelists, myself, Jerry and Katrina Rack. So the first question we've got is, could you explain a bit more about the process for the CLL, TP53 and IGHV pilot EQAs? Would you like to answer that one, Katrina?
Yes, I can answer that question. So this year we're setting up a pilot EQA for TP53 mutation testing and IGH somatic mutation testing in collaboration with our sister organisation, UK NEQA's LI. And we're also running this EQA in collaboration with the ERIC consortium, who currently organise certification process for both of these EQAs. But what they don't or want to provide is a follow-up assurance of quality testing. So we have agreed with them that all laboratories who are EQA certified for either of these testings can now enroll in the GenQA collaborative EQA to follow up the assurance of testing in these two spheres. So these EQAs are currently open for enrolment. We are only taking enrolments from laboratories who are ERIC certified. So if your laboratory is ERIC certified, please sign up. If your laboratory is not ERIC certified, then please go to the ERIC website and they will allow you to register for certification. The advantage of certification prior to enrolment in EQA for these two testings is that you will get a lot of specialised feedback from laboratories who are already currently running these tests. They have a dedicated helpline to help laboratories with any problems, and they run regular workshops. And so this is a good basis to assure that your laboratory is working to a very good and high standard before participating in EQA, where obviously if you get a poor performance, this is quite a large problem for the laboratory to deal with.
Okay, that's great. Thank you very much. And second question we've got is, how do you go about choosing the cases for these haematological EQAs? Jerry?
We're totally reliant on our suppliers, really. So we will get our assessors who will say, we've got an interesting case. Can you, would you like us to send us some material? So it may be DNA, it may be fixed cells, which will then send out to our assessors, who will have a look at the quality of the material, look at the clinical background, and say yes or no, this is suitable material for a EQA. And every year we'll have at the end of a EQA season, you will have a meeting with our haematology specialist advisory group, and we'll have a discussion at the end with regards to what we've done in previous years. We don't want to be sending out the same equivalent type of samples and same type of testing year in, year out. So we want to keep it interesting and enable our participants to experience other aspects of that clinical testing. But as I say, we are totally reliant on our suppliers to provide us with useful material, and this tends to go through our assessors who say, we've got something interesting, would you like some of this to have a go at? And it may not be good enough, it may not be relevant for an EQA, but we'll make that judgment with our expert assessors.
Thank you. Yes, and as you said in the presentation as well, the EQAs are evolving all the time with the diagnostic services. So we're trying to cover all the bases, aren't we?
Yeah.
Okay. So following on from that, we've had a question about if there's oversight of these EQAs. As part of GenQA, we have the specialist advisory groups and specialist advisory boards, and these are experts in the relevant fields. We make sure that the assessors rotate, and so that we're aware of local variations, and our experts provide oversight advice on the EQAs delivered by GenQA. The experts also work with the GenQA staff to help source the samples, like we've just said, and put together relevant cases and review the marking criteria. And we make sure, obviously, that there's expert oversight for any appeals, that these are reviewed externally, and procedures followed following on from that. Okay, so we've just got a couple more questions. Katrina, could you answer why we are doing a BioNano exploratory pilot EQA? This is something new.
This is something new. So BioNano is a technology which allows structural rearrangements as well as copy number rearrangements to be determined in a single analysis. So it has certain advantages over the traditional array-based EQAs or testing. It currently has very few labs where it is installed as a technique, and several of these labs are still going through the validation process. So before we introduce it as a technique that's acceptable within our current EQAs, we want to actually evaluate how labs are processing the analytical output of the BioNano technology. And more importantly, we want to actually test the sample type, because this EQA or this testing requires a different preparation of DNA. So we want to be able to assure that we can source sufficient DNA prepared for this technology. And we also want to make sure that this type of DNA is stable enough to send out to participants, and then they will get a valid result. So this year we are carrying out a very small exploratory pilot where we will only invite labs that we know are using this technology to participate. And if we get good results and we've showed that the DNA is suitable for EQA, then we will introduce this as an additional technology within our existing EQAs. And we will feed back the results of this survey to participants.
Okay,
So,
brilliant.
can I add to Katrina's answer there, please, Melody?
Sure,
I mean, this was this also came up in this year's acquired array EQA, that one of our participants, who was also one of our assessors, said he wasn't going to be entering, his lab for the acquired array for this year because they were moving towards that sequence base. So yeah, we are looking to sort of move as our participants tell us that's what they are doing. That they are moving towards sequence-based technology to give the same answers essentially as the copy number changes technology.
Yeah, I think we're very aware that labs are changing their approaches, and they are contacting us because obviously they need EQA for their own accreditation purposes. So once we know that there's a sort of minimum number of labs performing a certain type of technology, then obviously yes, we consider that as take that on board, and we'll consider setting up EQAs to address laboratories' needs. So it's very important that laboratories, get in contact with us and follow. We will be carrying out some surveys, so please, feedback developments in your lab and where you see EQA needs in the future, because this informs us then and allows us to develop.
Yes, and our move towards organising the EQAs along the disease pathways should help with that as well, and we can incorporate the different technologies within the different diseases. Okay, so another one for you maybe, Jerry. What do we do if we think we've been wrongly penalised?
Well, that would never happen, obviously, but should, on the infinitesimally small chance that happens, we, as I say, we're not out to punish laboratories, and we're human, and our assessors are human. So we have a assessors meeting when we're ready to publish our individual laboratory reports, and we look for differences, that someone may have spotted something someone else hasn't, and that process may actually continue a further step, that after the reports have been published for the laboratories, that someone points out something, as I say, a footnote, a additional statement that we'd
maybe not picked up on in the analysis process. So we are very receptive to appeals. Obviously, the appeals have to be evidence-based. So if someone feels that they're being unfairly penalised, or that we have given an unfair comment in the report, we are happy to reassess this, but only with the information originally provided. And if we think we have given an inappropriate penalty, we'll hold our hands up and we will refund that penalty, as it were, and apologise profusely.
Okay, and so we've just got time for one more question. So does trisomy 12 in CLL have any prognostic implications? And if not, why do we do it? Katrina.
Yeah, well, trisomy 12 is part of the original panel of 4 tests that were proposed for CLL many years ago. It's considered to have an intermediate prognosis. Some labs will choose to do it, and that's the right to do so. Many labs, I think nowadays, currently tend to only do T53, which is the recommended minimum testing to do, and ATM. So it's basically a laboratory decision on what panel of FISH probes or what approach that they want to take. And our attitude is that that's fine, as long as they do FISH for T53, because that's the essential test, that's the critical test for us. We will include trisomy 12 on our panel of results, both for the FISH sample EQA and as images for the online EQA, because we know that for some laboratories they still will currently use this FISH probe in prognostic testing. So it's there to allow laboratories that do perform trisomy 12 routinely on cases to be able to assess their results.
Okay, great. Thank you very much, everybody. So I think that's all the questions we've got time for today. We're always obviously very happy to receive feedback on our GenQA services. We will be sending a survey out to all the registered participants who have registered for this webinar to get your feedback on how things have gone for you. As a registered participant, you'll have priority access to this webinar for 1 month. If you're unable to join us live, or if you had any technical issues during the presentations. You'll be issued a certificate within that email linked to the survey. You'll be able to view the webinar live once it's not live on the YouTube channel, where you can subscribe to our GenQA channel. As I said at the in the introduction, this is a series of webinars that we are now doing called the Focus On sessions. If you need any further information, or if you want to see which topics will be covered in the future, please look on our website. The next one that we will be doing in September will be on pre-implantation genetic testing. And obviously you can always contact us directly if you need any more information. If you look on our website, you'll be able to see all of our contact details. So I hope you've enjoyed this session today, and we look forward to working with you in the future. And as I said, any feedback is very welcome. Thank you very much.